Another way to implement a hierarchy of objects is by using something called an interface. An interface is a contract stating that you're going to define a list of methods in the interface and that any class that tries to use the interface, what we call implements, must define those methods listed in the interface definition. That probably sounds a little abstract to you, so let's look at an example to make it clear. We're going to start over again with the shape class, except this time it's not going to be a class, it's going to be an interface. So we'll get started. We'll open up our file, shape.java. And here we're going to type public interface shape. So we replace the word class or abstract class with interface. And then in the definition, all we're going to do is list those methods that need to be part of any class that implements the interface. So for a shape, we might need our XY coordinates to be able to set them and get them and to be able to draw. Those are the basics of any shape. Of course, things like rectangles or have widths and heights, which are not under the control of the interface. But all shapes have an XY coordinate and are able to draw. So we can list those as required of all classes that implement the interface. So we'll write public int getX first, and then public int getY. Notice that we do not provide definitions. It's up to the class to define what the method is going to do. All we're doing in the interface is specifying what methods must be defined. So then we'll have a public void setX, int xcore, and then a public void setY, int ycore, and then a public void draw. So those are the methods that we're going to insist that any class that implements shape must define. So let's save the file and let's compile it. Make sure it compiles, and it does. So now we're ready to create a class that will implement the interface. So we'll start over again with rectangle. So to implement the interface, we write public class rectangle implements shape. So implements is the keyword to use to indicate that rectangle is being built from shape. So we still have to create data members. Notice we didn't have any data members in our interface definition, so we need the data members for the class. So X, Y, width, and height need to be declared. We need a constructor, so we'll do that real quick. We'll make it very basic definition to save a little time. Okay, now we're ready to implement the methods that were defined in the interface. So first we have public int getX, and that returns X. Then public int getY, which returns Y. And then public void setX, int X coordinate. X is equal to X coordinate. And then public void setY, int Y coordinate. Y is equal to Y coordinate. And now we need to implement draw, but I want to show you the error message you get if you don't implement all of the methods in an interface. So let's save the file, clear the screen, and now let's compile rectangle. And you'll see we have an error. Rectangle is not abstract and does not override abstract method draw in shape. So clearly we violated the contract by not implementing all of the methods that were specified in the interface, so we've got to go back and implement draw. So go back to our definition and write public void draw. And we're not going to do anything more than just that. Again, I'm not interested so much in the nuts and bolts of this definition as showing you how the overall implementation works. So now we can save the file and compile it again. And there we go. So that's how you develop an interface and then create a class from that interface. The interface is nothing more than a list of methods that any class implementing it must define. So like I said before, we're creating a contract, and the compiler enforces it by comparing the interface with the implementation, the class that implements the interface. And if a method is missing from the implementation, then the compiler lets you know that you haven't fulfilled your terms of the contract. So interfaces are yet another way to help build complex hierarchies of objects in Java. So that wraps up this chapter on polymorphism and some more advanced topics in object-oriented programming. And now we're going to move on to the lessons.